Good afternoon, ladies and gentlemen. The Hurricane Watchman is here with your latest update on the tropics. So, today we're going to be doing an update on a video update on Invest 96W. Because it is actually headed west and is expected to intensify into not only a tropical depression or tropical storm, but possibly a typhoon later on as it approaches the Philippines. So, we're closely watching it. There's lots of convection. We've been watching it, and there's actually quite a lot of deeper convection towards the south. This is currently what the models are showing right now. 1,002 millibars, as you can see, here is where it's currently located at. And it's expected to go roughly in this general area. But by the time it makes landfall, we could be seeing a strong Cat 2 or even a Category 3 typhoon as it makes its way into the southern portions of the Philippines in this general region. So we could be seeing winds as high as 100, 105, 110, even 115 or 120 miles per hour is possible. That's generally going to come into here. Then it shows it come south, and it could do a turnaround like that, or it may just go straight out. But that's quite a ways out from now. But right now, the biggest and closest thing we need to watch out for, how fast does this intensify? Is there wind shear? Is there dry air associated with this tropical system? What is it going to do as it makes its way towards the Philippines? So right now we got to watch how, its intensity and how fast it intensifies. So there's Invest 96W, as you can clearly see right here. Deep convection within it. There's actually down here there's a big blob of convection. This is an old picture. This was at 03 UTC way early this morning. So that's what we're watching right now. Looks way better this morning than it did last night. So we're going to talk about the text and also just sort of talk about what are we looking at, what are we dealing with this tropical system. So this is from the Joint Typhoon Warning Center in Pearl Harbor, Hawaii, United States. So again, there's in fact a tropical cyclone formation alert for Invest 96W. And they're saying that a significant tropical cyclone is possible within 135 nautical miles either side of a line from 5.6 degrees north, 143.7 degrees east, from 8.1 degrees north, 138.2 degrees east. So that's really what we're dealing with. And this could be issued within the next 12 to 24 hours. Now, at this moment, the available data that they're given does not justify the issuance of a numbered tropical cyclone warning at the time. However, the winds are estimated between anywhere from 15 to 20 knots. That's about 20 to around 25 miles per hour. Satellite imagery indicates that a circulation is centered near 5.6 degrees north, 143.7 degrees east, and the system is moving west-northwestward at around 11 knots. So, again, there is a very weak vertical wind shear, about 5 to 10 knots. They're starting to see radial outflow. The global models agree with the European model, jumping on the development of this, on the bandwagon that the system will in fact intensify in the next 24 hours. And generally, the storm is going to track west towards the Philippines. All right, and so again, winds anywhere from 15 to 20 knots, 20 to 25 miles per hour. The air pressure is around 1,007 millibars. Now, the potential for tropical cyclone in the next 24 hours is high. This alert will be reissued, upgraded to warning, or canceled by 3 UTC, the 13th at 3 UTC, and they have not canceled it. So this is currently what we're seeing here on radar. So you can really see that deep convection blowing up down there. That's what we're watching, this deep blow up of convection right here. It shows the atmosphere is very unstable. It shows there is deep warm water. There is not a lot of vertical wind shear. They're going to be seeing more convection throughout the day. You can kind of see this blob up here, this up here, this here. And I think we're going to start to see more convection near the center of circulation throughout the day today. So if we take a look at this is so you can in fact see there is more convection down here. Infrared, yeah, infrared's pretty good. So you can kind of see with what we're dealing with this system, deep convection near the deep convection down here. As you can clearly see, we're talking anywhere from -7, -80, close to -90 degrees centigrade cloud tops. So that's what we're looking at right now. So lots of deep convection, which shows again the atmosphere is very unstable and is allowing for the storm to fuel itself. Very, very, very warm waters. Very, very warm waters. We're going to see more convection near the low level circulation, near the LLC later on in the day. Now again, these are what the models are currently showing right now. As you can see, some models are saying it may drift south a little bit before making its way westward, and then do northwest or northwest, west northwest, and then generally it's going to move due west as it really begins to intensify prior to landfall. So I mean, maybe a little bit dip of a south, then northwest, and then west. This could be what we're dealing with, but generally the southern portions of the Philippines are going to be impacted the most. Central southern portions of the Philippines are really going to be impacted the most. So that's what we're dealing. That's what we're looking at. That's what we're dealing with this system. Now again, if we're taking a look and we're looking at the visible satellite, again, the storm looks incredibly healthy right now. Very, very deep convection, like I've said, near the low level circulation. As you can clearly see, look at that. You can clearly see we're dealing with convection. Again, 20 knots, 1,004 millibars. Air pressure continues to drop. So the air pressure continues to drop. There continues to be lots of convection. Clearly, you can all see all this convection right in this area. And that's something I'm a little bit worried about. We're actually starting to see a little bit more convection as I'm making this video right there near the low level circulation, which indicates that we could see the atmosphere gets unstable. Lots of upward motion in the atmosphere. And again, the reason warm air rises because it's less dense. It's less dense because warm air, the molecules are farther apart. If I'm wrong, I do believe the molecules are indeed farther apart when it's colder. The molecules are closer together, and they're more dense, and it sinks. That's what high pressure is. High pressure is sinking air in the atmosphere, which limits the development of tropical development, and we're not seeing that here. We're seeing air moving up. And then we're soon going to start to see this outflow here. So the air comes in, and it is pushed away. Air then comes towards the system at the low levels. The air comes fast in the low levels to replace the air that's being shot up out at the top of the storm. That's kind of like exhaust. The air is coming up and out. Air at the surface are going in to replace the air that's coming out of the system and out at the top. And so it's kind of this motion, and that's kind of how hurricanes work. And so that's what we're seeing here, and that's why the air pressure is dropping, because you got air coming in and it's going out, and it's coming in faster. And as the wind goes fast, as the air pressure drops, the air is going to try to replace it faster and faster and faster. The faster it happens, the faster those winds are going to be. So that's sort of what we are dealing with when we're dealing with strong winds and hurricanes. So that's what we're seeing here. I could have looked at something else here. So again, this is just satellite imagery, really kind of talking about it, watching what we're seeing here. So that's kind of what we're watching. The wind shear is very low right now. This kind of is just kind of like the Dvorak scale, kind of shows you the shape of the storm. So again, clear, huge blow up of convection here. We got, I want to say this is outflow here. You might have the LLC here. Probably going to start to see outflow develop here, outflow there, which means the air is rising up and it's being shot out at the upper levels. And wind at the low levels are coming in. You can actually see this on really powerful storms. You can see clouds at the lower levels of the atmosphere are going in the storm, and clouds at the upper levels are going away from the storm. You can really see that when you really look at really powerful hurricanes in the Atlantic, West Pacific, and elsewhere. Now this is really cool. You can really see, this really helps to have an idea, what are we looking at, what are we dealing with, you know what I mean? Clearly, you can clearly see, so freaking slow. Again, we kind of having, again, I'm assuming the low level circulation somewhere around here. You clearly have a stream of outflow here, and maybe something here. So those clouds are going those winds are going away from the storm. You can kind of see, and then you're gonna have at the surface levels, you're gonna have winds sort of maybe going towards the storm at the low level. So again, the air coming up and out of the storm is going away, which drops the air pressure, but at the surface, wind is trying to replace that pressure dropping, but because it's not able to do it fast enough, the air pressure continues and continues to drop. Now, if that never happened, the air pressure will continue to drop, and that's just not really how weather works. It doesn't just drop forever. There's a point when it reaches a maximum, you know. All the atmospheric pressure dropped to zero, the ocean would boil. But that's something for something else. So that's like it's a astronomy and stuff like that. I'm not into that. Anyway, that's what we're dealing with that. Kind of wanted to show you this satellite imagery. Really, really cool stuff. Again, this is Invest 96W, which you can clearly see. It's nighttime. Very, very clear. Very, very crisp. If we take a look at... Again, you can clearly see what we're looking at. Clearly see what we're dealing with still. Still seeing huge amounts of convection here. Again, still talking about that outflow here. The development of this possibly developing into some outflow. This could be some outflow here. You can kind of see, you know, this is going away from the storm. This is going away from the storm. And again, at the low levels, you have wind coming towards the storm to replace the air that's being rushed out at the upper levels of the atmosphere. And that air that is being replaced is the hurricane force winds that you feel during a hurricane. Really interesting stuff. That better be right. So again, this is Invest 96W, and again, this is generally what we're looking at with this system. So currently, it's way down here, and it is expected to generally continue to intensify into a tropical storm, and it could potentially, again, by possibilities of becoming a major typhoon, in terms of like hurricane, major typhoon, with a Category 3 or stronger, could certainly be a possibility. So if we look at the, these are all these. This is the track where they think it's gonna go. You can see the intensity, what they're showing in terms of intensity. You know, this is, I don't know what best means. I don't know what model that is, whatever. Generally, it's going to continue to intensify over time. Intensity and MSLP, they're saying some could drop to as low as, okay, these are by 5 increments. So down to here, so maybe as low as 955 millibars or so. It's certainly a possibility. Wind swath. So these should be in knots. So they're showing generally where the storm goes along this path. Through here, the winds are going to generally become stronger. In this storm, you can kind of see 50 knots there. And then the yellow, we start to see hurricane force. And we even see some red, which is way up here, 96, 83, 96 knots. So that could certainly be a possibility. That may certainly be a possibility where we start to see relatively strong winds right here. Now again, the green is just 34 knots. That's tropical storm force wind field. The rain swath could also be a problem. Again, this is in fact going to be in inches, as you can see here. Inches. And you can see generally we're seeing 2 inches of rain in the outer areas, but closer towards where the storm's going to be, you're going to see you could see 4 to 8 inches of rain. Other areas see 16 inches of rain in the oranges. Reds are in the 24 inches. I even see some pink there, right through here, which is going to be 32 inches. Jesus, that's a lot of rain. As you can see, so generally, as it approaches the Philippines and this general region, we see 4 to 8 inches of rain. Isolated areas could see as much as 16 inches of rain. So flooding's going to be a problem. Mudslides are going to be a problem. Landslides are going to be a problem with this storm. The storm is just going to progressively get worse. The conditions are there for the storm to become something bad. Everything is there for the storm to develop into something potentially catastrophic. Probably it will not be catastrophic in my opinion. It will nothing be like Haiyan, but it's going to be life-threatening. You're going to have life-threatening rain. You're going to have potentially life-threatening flooding and the possibility of storm surge. I mean, think about it. It's way out here. It has hundreds, maybe even over 1,000 miles before it actually makes landfall. So the more water it is able to get up, the stronger those winds get, it's going to create a wave. The wave is going to be created. It's kind of like you have the wave. It's kind of like storm surge is a wave underwater. As the water gets shallower, it buckles. All right, the wave begins to buckle and rise, and that's why it's so dangerous at landfall, because it's almost like it can almost be like a tsunami, like with the Yusai Haiyan. It develops so far away, but it continued to be super duper strong, making landfall with winds of nearly 200 miles an hour there in the Philippines. I believe it was reported at 196 miles per hour. So, let's see. So again, with this system, you can kind of see this is the low-level circulation right here. Wait, let's see. That seems pretty far south. Wait, this is where it's at. Yeah, this must be where it's at. So this is deep layer mean streamline. Okay, so yeah, that's where it's at, and it's generally going to go in this area, moving somewhat west-northwest. This is wind shear. As you can see, there's really low wind shear. Very, very low. 10 to 15 knots. Right where the storm is at. Wait, can I zoom into this? It's going to work like that. Okay. So generally where the storm is at right here, it isn't generally low wind shear. And I think it's going to weaken. I think this wind shear is generally going to weaken as the storm continues to progress towards the Philippines. Jesus. Jet stream right here, I think. A little low. That's high pressure. So the reason this is staying so far south is because of high pressure. Let me make this blue. It's because of high pressure. You can see there's this like boundary sort of around it, and that's why it's going to kind of be staying south. But I believe this will be moving west or to the east because of this ridge right here. I'm going to pull it off to the east. And as that happens, this is going to be able to gain some latitude and make its way. But it's not going to gain latitude and completely miss it or make landfall in Manila. Excuse me. But it's not going to impact Manila very much at all. This is vorticity. This just basically shows you the spin in the atmosphere at 500 millibars. 500 millibars is the mid-levels of the atmosphere. 200 millibars is the upper levels. 500 millibars is the mid-levels. 700, you're starting to get to the mid to lower levels. 850 is the low levels of the atmosphere. Alright, so this is currently where that system is at. So this, basically what this is showing is spin in the atmosphere. There's a little bit of spin. You can kind of see those colors there. This is really going to, you're really going to be able to see the spin in the atmosphere really a lot better as that storm as we see the storm progress through time. So if I put this into motion, you can really see what they're showing here. Much more spin in the atmosphere. Look at the spin. A lot more energy going on down there. This is surface pressure. So as you can kind of see, you know, reds are above. I think blues are below. So you really see all those blues there. That shows air pressure that's below. That's lower air pressure. That's generally what you're gonna see with a tropical cyclone. Oh, there's so many things to look through. I could be here all day. This is wind. This sort of talks about wind. What is this? Radar reflectivity. Undefined. Okay. Thickness. What's this? Let me see. This is, excuse me, vorticity and wind. They just basically show. Gosh darn, I don't know what all these maps mean because I'm still learning. This is relative humidity. So that just basically shows you how much moisture is in the atmosphere. If it's below, usually, and once we get down about 50% or lower, that's when it's not the best. But the darker these greens, we're seeing 80-90% humidity. That shows there's not a lot of dry air, and that the storm is able to really develop much better, and really able to really develop much clearer. Look how tight that gets. You can clearly see how tight that storm gets. Oh, this is MSLP wind. So these are knots. I completely forgot about this. So if I go in time, you can really start to see we're at 20 knots. But once we start to see the blues, ladies and gentlemen, is when we're really going to start to see those tropical storm force winds develop. We continue. 64 knots is hurricane force. And I don't see any greens yet, thankfully. Really starting to see tighter. We started to see 988 millibars right there. There's those greens right there. This is approaching the Philippines here. We really start to see those greens right there, right as it begins. And you can even see the yellows. So 970, 960, maybe even the 950 millibars as the storm begins to approach. Even the oranges at 96 knots. 960. So that's really what we're starting to see. Ooh, what is this? Okay, so... Alright. Cross-section, total winds and knots. So these are at the low levels of the atmosphere. These are at the upper levels of the atmosphere at 100 millibars. I think 1,000 millibars. This shows temperature. Okay, this shows cross-section for total wind speed. This shows relative humidity at the different levels of the atmosphere. Oh Lord, this is going to be confusing, I think. Oh, this is this is what this is. So this is basically a cross-section. You'll be generally able to see where the storm is. You'll be able to see the eye wall. And you'll actually be able to see the eye of the storm at the different levels. So if we go to where the storm really makes landfall, look at that. So basically what this shows is this spot right here. Okay, blue is not a good one to use. I have a thing for pink, all right? Why didn't I oh God. This right here is the eye. This right here is the eye wall. All of this is like the eye wall right here. This is the eye wall. This is the eye wall. This is the eye of the storm. Now what I want to point out to you, I think this is true. You see how it's really tight down here? But up here it's much more farther out. I think that's because the winds kind of come out and they spread away from the storm. Now if you have outflow, it basically pulls energy away from the center, which allows the storm to breathe. And the reason you have such strong winds is because you have winds coming in to replace that air that's being sucked out. You really can't see any of my arrows, but gosh darn it. No, not what I meant. Screen go. So that's what we're seeing there. So that you can really kind of see the eye wall. really develop here. But then you can kind of see as the storm goes over land. You can see it develops, and it kind of gets all flipped up because it goes over land. And so that's why you can't really see an eye wall. It's all tilted over. Because you got winds, strong winds over here, you got strong winds up here, strong winds over here. So it's kind of tilted. Alright, and so it's kind of what mountains do to it. It kind of messes it all up. I feel like I'm making a lesson out of this. This is the GOES infrared satellite. So this is basically, this gives you an idea of what we're going to be looking at here in the future. Oops. So you can kind of see the storm blowing up. Wow, look at that. So, wait, if we do WV, this is, so you can really see. Let me just, almost looks like an eye tries to develop. Look at that. Now this is kind of showing some possibly dry air trying to get in. Maybe that could be an eye trying to develop. Generally a calm area. Could be some dry air trying to get in. Same with maybe some drier air trying to get in here. But there's so much moisture in the atmosphere. I don't think it's going to be very successful. This is a very tropical climate. So really isn't a big possibility of a lot of dry air getting into the storm. But I do think it tries to create a little bit of an eye. You can kind of see that right there. Some dry air trying to get in. Same with this. Dry air trying to get in there. But I don't think it's going to happen. You can generally see it's a lot neutral moisture. Much dry air down here. Much dry air over here. Lots of moisture here. So dry air sinks. Moist air rises. That'd be cool. So you can clearly see the low level circulation. You can really see what tries to develop. What I really want to point out is that it tries to develop some sort of an eye here. You can see that there. Lots of, I do think there's a lot of energy in this storm once that develops. The possibility of that is a possibility in my opinion. So if I put this into motion, you can really see the eye right as it makes landfall. So I do think the possibility, there certainly could be a big possibility of this developing into an eye developing out of this. It's a little bit different, but still you can kind of see possibility of an eye trying to develop. This is just wind structure of the system. So this just kind of shows this one right here. I don't know what tangential wind means. I'm still learning horizontal wind is west and east. So you can kind of see the eye. You'll see what I mean. You can literally see a calm spot, and that's where the eye will be. Boom, right there. Look how calm that spot is. Extreme winds, nothing. Extreme winds, you know. So you can see the eye developing right there. Strong winds on the west and east side of the storm. This is divergence. I think that's like outflow. There's just a lot of really incredibly fascinating stuff. This is surface temperature, humidity, wind difference. There's just so many different types of models we're looking at here. So many different things here. Wow, look at that. This must be rain. It just shows you the amount of rain that we could be seeing. So this is like a radar, essentially. It looks like. You can kind of see the storm spinning. Look at that. And look at that eye. Look at that. That is fast. That is just mind-blowing. ATCF, I think, is... What is ATCF? Ship's diagnostic. So that's what we're looking at here. That's what we're going to be watching. So, again, that's what we're going to be looking at here, ladies and gentlemen. We're going to continue to closely monitor this storm and then over the next several days. And obviously the development of this is on our minds. We'll give you more tropical updates on this one and other systems throughout the rest of the day. So this is going to be posted soon as I possibly can. That's me of today, guys. Have a wonderful rest of your afternoon, evening, or morning. That's it for today, guys. Don't forget to like this video. And we'll see you guys next time. Peace out.